Okay, let's start with unit conversion factors. This will be a very short presentation. Um, However, it is the same method used most of the time to convert units. So if you master it, you don't have to learn it again. What is a conversion factor? They come from what I call unit equivalent equations, like the following examples, where you have 1 inch equals 2.54 centimeters. If you divide both sides by 2.54, you get 1 centimeter equals 0.4 inches. 1 kilogram equals 2.2 pounds. If you divide both sides by 2.2, you get 1 pound is equal to 0.45 kilograms, and so on. And you could check me on these values here, but you could use this for any unit, whether it be converting liters to centimeters cube, any unit you're converting, as long as you can find one unit that leads to another, and you'll see that in the next couple slides. The unit equivalent statements are rewritten as fractions in preparation for conversion. So you'll usually write your unit equivalent statement equation as this: 1 inch really equals 2.54 centimeters. These units do not cancel, and these values are as they are. 2.54 centimeters of 1 inch means that 2.54 centimeters are in 1 inch, and again they're equivalent to 1, and as you saw earlier. So what we do now is we take these fractional forms of the unit equivalent statements, and this is your conversion factor. So you multiply the conversion factor times a unit to convert. So this is the unit you want to right here, 3.4 centimeters into centimeters, and the converted unit must cancel out. So when I multiply this factor, there must be this one unit in the numerator and the other unit in the denominator to cancel out. They can't be both in the numerator or both in the denominator, otherwise the conversion factor is not set up right. So this is in the numerator, inches in the numerator, inches in the denominator here. That cancels. That means we're appropriately using the conversion factor, and you multiply the numerators together and then you multiply denominators together. Of course, you'll get your numerator here, denominator here, and then applying your significant figures rules, you should end up with 2. So hence this is your response, your answer here, 8.6. Convert 1.3 days into seconds. So we have 1, 2, 3 conversion factors that we're using here. These two conversion factors could be combined into one, where you'd have 3,600 seconds for every hour. And we know there's 24 hours in one day, and the units cancel, days cancel, hours cancel, minutes cancel, you're left with the seconds. That means that your conversion factors were used appropriately. Again, that one has to be in the numerator and one has to be in the denominator. And the other item that you'll run into is when you have squared units that you need to convert. And all you have to do for that is you have to square the conversion factor. So if this is a cubed, you'd have to cube the conversion factor, but the conversion factor is still what it is. You're just cubing the numerator and denominator, as applies to the rules for whenever you have a fraction to a power. The problem here is we're converting 4.1 meters per second squared into centimeters per minute squared. And so we have our original value and our unit, the unit value here. We're converting meters to centimeters here, and that's not squared, so the meters end up canceling. And then to convert seconds squared, we actually need the conversion factor, but we're going to square it. So what it ends up with is 3,600 seconds squared over 1 minute squared. So we square the numerator, square the denominator. So we get 1 squared is 1, 60 squared is 3,600. So then you have centimeters here, and then you have seconds squared here, cancel with seconds squares here, and then you're left with the units that you're interested in, what you're trying to convert to. And that's how it works. And it works like that all the time. Your job is to find out what these equivalent statements are, to make the conversion, use them appropriately, and then convert your value with its appropriate unit. Enjoy.